Hello, everybody. Muted. Hello, everybody, and welcome to the weekly dev stream. There we go. Hello, everybody. Yes. Very stressful day today. I was running around trying to arrange for this stream to happen. There's a lot of stuff to talk about today. Just barely made it in time with everything that I need to do for today. And not only that, but I accidentally deleted all my save files on my fucking hard drive. So that happened. Don't forget to back up your saves, y'all. I know I did. Hope gladly I did. But it's just so funny that I fucking did it myself. So it can happen to anyone. It can happen to anyone. It can even happen to me. So always make sure to back up. So this is your like reminder to make sure to back up your save files. So no, what I did was I'm jumping back and forth a lot between like. Actually, I don't need to explain that. Essentially, what I did was I opened up the folder and I was like holding down Shift while I was doing it, and I accidentally hit delete, which is just like I just nuked my entire factory folder. What I did lose was all my config, which is a bit annoying. And if there was anything else in that folder, which there probably was, that's gone. But yeah, I accidentally did that. And I didn't realize until it was too late that I probably should have just done like Windows recovery file thingy. And at the time I realized, oh, I should have done that. I already wrote to my hard drive, so it already overwrote it. But it's fine. It's fine. It's probably fine. It's probably fine. I'm gonna probably find something else in that folder that I probably needed to do. So my saves are fine. It's everything else that was in that folder, which at the moment I don't know what it was. So I guess I'll find out when I need that, I guess. Anyways, welcome to the weekly dev stream. This week is gonna be a little bit special. Because this week we're going to spend the entirety of the stream talking about the video, or not the video per se. We're going to talk about the content of the video that Jace put out last week. Well, I say Jace because it was me, but Jace was in the video. So we put out a video last week, if you didn't know, about that fact that we are upgrading the game to Unreal Engine 5. Which is a pretty big deal, I would say. There's not a lot of people that, well, I say that, but Epic also the day after announced that like 77% of games built in Unreal Engine 4 are moved to Unreal Engine 5. So I think a lot of people are making this move, who are currently developing a game in Unreal Engine 4. But we've made the move. And we have made the move a while ago, actually. It's been a bit awkward on stream to be like, yeah, we don't know if we're gonna do it. We knew, but we kind of didn't want to like talk about it on stream before we announced it in this manner, for a couple of reasons. One of them is mainly because there's a lot of implications into moving until Unreal Engine 5 that I don't think everyone is aware of. So the thing that we were scared of, if we just announced that like, hey, we're moving to Unreal Engine 5, a lot of people will have like different views on like, what does that mean? Like, or have like ideas in their head as like, oh, maybe Satisfactory will have like a bunch of Nanite shit and Lumen shit and all that stuff. Like, we really wanted to clarify in one setting, in like one video, preferably, like this is everything that goes into what an upgrade is. And we didn't want to do that on stream because not everybody watches the streams. Not everybody knows about the VODs. We want to have like one concise place where we could put all that information as to like what the move to Unreal Engine 5 would mean, to not like have this issue of people spreading like, you know, rumors or misinterpreting what that means and like build up hype for something that we're not gonna be able to support, etc., etc. So making that video was really the only way we saw fit that we could announce that we are moving to Unreal Engine 5. And it was, I don't know if you realize, but it was a beefy fucking video. Okay, it's like the original draft was like was an hour, I believe, or 50 minutes ish, and then we cooked it down to 40. Which is the current one. But I think it's really important that it's like, I think it's really important that we are clear as to what we can and cannot do in Unreal Engine 5. Now granted, even though we put out that video, there's still a bit of misinformation out there as to like what this means. So I'm gonna try and clarify as much as I can in today's stream. So we're gonna spend the entirety of the stream talking about this today. It's a shame that originally we weren't supposed to release this video now. We were supposed to show off more stuff before then. There's other stuff in update 8. Okay, guys. I also saw that a lot of comments on the internet that people were like, "Is this the only thing that's going to be in update 8?" No. Unreal Engine 5 is a huge part of update 8. It's from our part, like the vast majority of our effort has gone into supporting Unreal Engine 5. But that's not everything that's in update 8. There's a lot of other stuff too. And we wanted to sort of tease some of that stuff, but as you now know, because we moved to Unreal Engine 5, a lot of tools that we use to like capture in-game footage and like generally capture like, yeah, the stuff that I do essentially to make the teasers and like the videos, all that stuff was broken. And all the tools that we use that are like surrounding capturing footage was also broken. So I had to, from scratch almost, recreate all those tools for Unreal Engine 5. And that took a lot longer than I thought. So we were supposed to like unveil stuff 2 weeks ago. And here we are. I still haven't quite fully finished the tools yet, but it is what it is. And we were supposed to like just push everything by 1 week, but then we realized that I'm not going to be able to make that either. So we're going to push things around, shift the schedule around a bit. I talked about this on last week's stream. Instead, we opened the gates with unveiling that we are releasing Unreal Engine 5 for Satisfactory. And there's more content, okay? There's more to update 8 than just that, okay? So don't worry, there's new stuff coming. Just bear in mind that update 8 is going to be similar to update 7, so don't expect like any major like new content in terms of like, you know, factory buildings or stuff like that. If there's going to be any more content like that, that will be in 1.0, essentially. So that will be further down the line. Because right now we're focusing on wrapping up the game so we can release 1.0. So that's kind of what's going to be, that's sort of, I guess you've seen the effort of that in these last couple of updates where we've mostly done, you know, a lot of tweaks to the game, like structure of like behind the scenes, such as an engine update. And there's also a bunch of like feedback fixes that we have, stuff like that. So, but there's more news on update 8 later. Right now, we're going to talk about Unreal Engine 5. And let's see, was there anything I forgot in my notes here to preface this? Yes, one thing that was quite annoying was that the day before release, we released this video, Epic announced, talked about Unreal Engine 5.2. We're not going to move to that engine, like to that version, for 2 reasons. One is that 5.2, which was like announced last week, Thursday, I believe, that's still in preview, and we never move production to a preview build of Unreal Engine. We don't even consider that as an option until sometimes we even wait for like one patch or like one like minor release of Unreal Engine before we actually consider moving to the next or upgrading the game, because usually you know, Epic are kind of similar to us, like they just want to get it out and then they realize like, oh shit, there's a bunch of issues, and then they patch it, and then the next patch is pretty much the finished one. So we usually wait like one minor patch before we even consider moving. As to like when that version will be out of preview, after that will we move to 5.2? That's kind of like, we'll see what happens. It depends. It's the same sort of procedure as always when we evaluate whether or not it's worth it. Depending a little bit of like where we are in production, it might not be worth it anymore to upgrade to later versions of Unreal Engine, but we'll see, okay? By the way, if anyone from Coffee Stain are watching this, as we go through all this stuff, if I say something that's incorrect, please write to me and we'll sort it out immediately on stream. But I'm essentially going to go off Jace's script more so than anything, and then dive into some things that people asked about that you might need some clarification. So let's just get straight to it, I guess. He's going on. No, I'm going on script as hell. Like, I'm going to be so on script. Right. I talked about the fact that we couldn't unveil Unreal Engine 5. The reason why was because we wanted to get, we wanted to do a proper Unreal and not just unveil and not just say update. For a couple of reasons, actually, and that's the two next topics that we're going to be talking about, and that's Nanite and Lumen. For those who don't know, Nanite and Lumen are two technologies, or I'd say technologies, within Unreal Engine that they made specifically for Unreal Engine. That one handles global illumination. I'm going to say GI from now on because saying global illumination over and over again is really tricky. So GI is global illumination, and then Nanite is like it's a what's it called? I'm gonna try and use the proper term, but it's essentially like a clustered way of calculating when you're looking at a model in 3D, which polygons are actually visible per pixel. Because you can end up in a situation where if you have a model and you move it way back, and the whole entirety of the model fits within 1 pixel, the shader is still gonna send all that data to the GPU, and it's still gonna do all the calculations of how to render, and then it's gonna find out that all that rendering is happening on 1 pixel, and then it just decides here's the color of that pixel. That's essentially what happens on the GPU, right? The GPU is essentially just taking data from what's going on CPU, and then it's calculating per pixel, what color should the pixel have based on what's being rendered on screen at the moment. And Nanite essentially boils models down so that it only essentially, this is dumbed down because there's a lot of techniques into it, but essentially it boils down to it figuring out what parts of a model are being rendered at the moment, and then that sends it to the GPU. There's a couple of limitations with that. One is that you lose a little bit of artistic control, because a lot of times you artists use normal maps and all those kind of buffers that come in with the regular old system of rendering, and you can sort of bake in more information and then kind of cheat the system a little bit. That is not possible anymore, so you have to go with the rendering pipeline that is designed for designed for Nanite. So because of that, we've decided to, well, not because of that, but that's one aspect of it. And for us, we're mainly going to use Nanite on the rocks that we have in our game, because the cliffs and the rocks are already pretty high, density-wise, polygon-wise. I remember one early meeting with Epic where they were critiquing us for having way too high fidelity, models for the cliffs and the rocks in our game. They told us that the only reason why you'd have this much fidelity for a cliff should be if you're making a rock climbing game or something like that, and that stuck with me really. So that is really useful for us to use Nanite for that. However, a lot of people have asked or talked about the fact that you can also use Nanite on foliage, and that's something that's somewhat new in Unreal Engine. That wasn't part of the initial release of Unreal Engine 5, but they've since added it because Nanite has the issue that a lot of times you can only use it for static meshes, which is meshes that can't move. Now, technically, foliage don't move, but there's a bunch of shader magic happening where you have leaves swaying and grass moving and stuff like that. So originally, it wasn't really possible to use Nanite for that kind of magic, but now Epic has support for that, so it is technically possible to use Nanite for foliage. However, we will probably not do that for a couple of reasons. One is that we would need to we have so much foliage in our game that we can't just press one button and convert it all to Nanite. We would sort of need to go in hand fix a bunch of stuff, and it would just be too much work at this point of development. If we were to start from scratch and have the knowledge that we have now, and be like, we're going to make Satisfactory, we're going to use Unreal Engine 5, we probably would have used Nanite for foliage. But as things are right now, it is probably not doable. The same question also comes to machines and stuff like that, using Nanite for that. I think that's something we want to do. It's the same kind of deal. There's a lot of resource that needs to be spent on sort of converting our models to be able to utilize Nanite. But that is more likely than converting our foliage to Nanite. So, which is a little bit of a bummer because we'll talk about it in a bit. But it's a little bit of a bummer because the biggest gain of using Nanite is really when you're rendering from a distance. So, and you guys will see that in a second, actually, because I've got a bunch of footage prepared for today where we will showcase some of this stuff. Yeah, so like distance, and Jay's talked about this in the video, where like if you're rendering from far away, you know, we can have higher density models for stuff further back. So like you could see the entirety of the world potentially in the future instead of like all those boxes and stuff like that. So that's Nanite. Lumen is another thing, and Lumen is, we're kind of supporting Lumen. We will have the option for you to be able to turn on Lumen in the game, and yeah, we'll talk about that too in a second. So I kind of forgot about this step, but I kind of want to go back a bit and talk about rendering in general too, and I have a little segment prepared here actually for that. So I saw a lot of comments from people saying that like the game is going to look so much better now that it's on Unreal Engine 5, and like that's one of the reasons why we moved. So the game will not drastically change in terms of what it looks like because we're on Unreal Engine 5. Just want to point that out, even with Lumen in a lot of cases. And I'm going to sort of see, I'm kind of curious actually, if people will be able to even spot the difference between what the game looks like now and what the game will look like in Update 8. So I have prepared a little quiz, sort of, not a quiz, but like here's a little game show here. So I've got, I have set up 5 shots, 5 different locations in the world. And I'm going to be showing you footage from Update 7. And I'm going to show you footage from today in Update 8. But you're not going to know which one is which. So essentially what we're going to do is we're just going to spam in chat which one you think is which one. So there's going to be 2 options. There's going to be A and B. Sometimes A is Update 7, sometimes A is Update 8, vice versa. So you never know. And then we'll have a reveal. Don't do it yet. We haven't seen the footage yet, okay? Calm down. So hopefully Mike should work in the scene. And let's dive into spot number 1. All right, here we go. So here's one spot. Here's A. Here's the game at this point. And then for comparison, we have spot B. All right. It's gonna loop again. So which one do you think is which? Do you think, which one is Update 8? Is B A or B Update 8? Ooh, a lot of B's here. Let's see, we'll go back to A here. Ah, interesting. Oh, we're going back and forth. I think I've seen more B's than A's though. Or maybe not? It's a little bit divided. I feel like people are mostly voting B though. All right, we'll see in 5, 4. Here comes the big reveal. All right, so A was Update 7 and B was Update 8 in this example. Yeah, so there you see the difference. Some of this stuff is like, I'm gonna pause here. Whoops. Let's go back to the video. Or not. There we go. So I'm just gonna pause over here. So some of this stuff though is that we've updated this biome a little bit, I believe. So like some stuff may moved around, possibly. but we'll see. So that was the first one. How did you all do? I feel like most people managed to see it though. So let's jump into the next one. So here we go. Here's another one. Here's option A, behind door number A. This is what it looks like. And then here's behind door number 2. This is B. So which one do you think is update 8? A or B? Let's see, huh? A lot of A's. I feel like when the thing is on the screen, I get more of one of them. But I feel like this is more... People are more leaning into A here. Very interesting. Very interesting. Yes. Yes, I guess we'll have to find out in 5 seconds. Here we go. Oh my god. Which one was it? A was update 8, so y'all got that one too. Hell yeah. You can kind of tell from... Let's see here. In this example, the fog is a bit more announced in this one because of, I guess, something rendering-wise, right? Because something is different in the rendering pipeline. I saw a lot of people mention the smoke. It's possible that the smoke has been updated. The VFX, that is. I don't know if that actually is changed, but yeah, look at that. Just counted the voxels. All right, let's jump straight into the third option here, and I think this is you're all gonna get this one. So, option 1, which is A. Could this be update 8? Or could this be update 7? Well, I don't know. Oh, do you guys know? And here's option B. This one should be... Yeah, look at that. A lot of B's. Y'all are catching on real quick here. Either you guys play the game too much, or you're just really good guessers. Which kind of gave that one away. With the fact that I'm saying that. The waterfalls? I don't know if the waterfalls have changed, actually. But yeah, let's see what it is. Could it be A or B? So update 7 is A, and update 8 is B. So this is a really good example, actually, of how Nanite like drastically improves the cliffs. So if you look here in the far distance on the cliffs, there's a lot more detail in update 8 than is in update 7, and that is because we get that that advantage of using Nanite on cliffs. So instead of using the loaded version of the cliffs, we can use like the actual model. So yeah, pretty dope. All right, spot number 4. Here we go. Here we are, Northern Forest. And here's option A. And then in a few seconds, we have option B. Which is ooh, this was a little bit more split, actually. Oh, a lot of split here. Okay, this one wasn't as obvious. B, poison looks more volumetric. I don't know if that has changed too much. Which is interesting, actually. Yeah, so the detail in B. All right. This might surprise you, chat, because A is actually updated in this instance. And this one is a little bit tricky because it actually looks like a downgrade in this. Yeah, a little bit bamboozled. Somebody mentioned there was better detail in the gas. I don't think it actually has changed between like update 8 and 7. But so the thing here, this is a little bit of a bamboozle because in update 8, we've changed the since we're moving the system, the world partitioning system. We are like loading in assets in a different way. So, and here we haven't fully set that up. Sometimes, in certain cases, it might not load in enough, sort of. So in this case, you don't see the entirety of the Northern Forest in the background there. You see like there's a little hole there, there's a gap, whereas here it's much more detailed. So here in update 8, in this particular spot, we're a little bit more Like, we're not loading in as much as we are in update 7. But that is also, we'll talk more about that, but that is also one of the drawbacks of how it is in Unreal Engine 4, the fact that we have to load in entirety of tiles, whereas now we actually do have the option to sort of load in half and half. So yeah. And then lastly, we have another northern forest spot. So here is option A, and then we have option B over here. Ooh. People going B. So with the knowledge, potentially, yeah, of what I told you just a second ago, it might be quite obvious. Yeah, it's true. Like, watching this on stream as well, you don't get the full, like, quality experience, if you will. But it is what it is. So what could it be, chat? Which one was it? I feel like most people... Yeah, it's update 8. Is option A is update 8. And B is update 7. Tricky! Tricky! Yeah. Yeah. It's not as obvious sometimes. So here's like actually the opposite. So here it actually does load in update 8. It loads better in this particular spot than what we're in originally. And that kind of stuff is stuff that we need to tweak. Yeah, baited. Actually, I wonder if I fucked up. I wonder if this is true, actually. I need to double check this. Yeah, I'm not sure if this is true, actually, now that I think about it. I wanna verify this. It's fucked up for sure. I wouldn't be surprised if that was the case. Let's see here. Let me open up the thing. But I think like the main point is I think most of you guys noticed because you're all diehard Satisfactory players. When I started playing update 8, I didn't really notice that big of a difference. But when you compare them side by side, it's quite obvious. Let's see, what number was that? That was 5. Let's see here. Fucked up. Yeah, I did fuck up. It's supposed to be the other way around. So we were not bamboozled. It was actually... I bamboozled myself too. I was like, wait, was it not that instance? But yeah, ignore that last one. Yeah, so W for this chat. So it was only really the second one, I think, or the third one that was kind of difficult to notice. But I think if anything, speaking of Nanite, and that's kind of wanted to get to this point really, was that not this one, was the fact that cliffs now look way better at a distance. So that's like one of the biggest gains when using Nanite for cliffs compared to the regular way of loading them, etc., etc. So yeah, I actually have more stuff on this though. Also, just want to mention that like the cliffs won't be like higher, like we won't improve the fidelity of the cliffs. Like they'll be the same quality as they are in the right now in the game. It's just that the loading is the major thing where it changes. So when rock climbing, that's a good question. Billboarding it, we were never billboarding the cliffs. We billboard the trees and like the foliage, and that will still be the case. Because, yeah, that's how it works. Let's see here. So Lumen, Jace mentioned Lumen. So Lumen is like Epic's GI system that they've made. Lumen is taking a lot of different GI like implementations and sort of baking them together. So I believe it's 3 different ray tracing techniques that are combined in Lumen, which makes it really powerful because it's really efficient. The one thing though is that Lumen is a software-based GI technique. So Lumen runs on your CPU, and it's more proficient running it apparently on the CPU than on the GPU, which is a bummer because Satisfactory is very CPU intense as it is. So adding Lumen on top of that is kind of annoying. But that's not really the main reason why we're not going to use it as like being the default supported one. So we're not going to like have the game be designed for Lumen in mind, because we've already sort of shaded the game with the current shading model that we have. And also the fact that Lumen is a software-based renderer, which makes it very taxing. And we're going to talk a little bit also as to like what other issues come with Lumen, because it's not all peaches, even if you have a good enough computer to handle it. But yeah, essentially, Lumen calculates like how light bounces around. It makes for a lot more like quote unquote realistic shading technique. And I also have prepared a couple of like example shots. And just want to preface again that we're not going to by default support Lumen, and we're probably not going to spend, I don't know if we're going to spend any time, but probably not too much time on like making sure the game works with Lumen in mind. But it is going to be there as an option in the options menu. It's going to be there as a setting for like global illumination, and you can turn it on if you want to. That's totally up to you. And we're going to check out what it actually looks like. So here is the default shading module. I think this is the most obvious one, I would say. So it's mostly like obvious in the shadows when you turn it on. And here's another one during dusk. This is the one that's a little bit trickier to see, but you can see some of the detail here on the ground. Some of the shadows look a bit more crisp. And here's one in the night, at the night, and this one is a little bit trickier to see. The only way I really spot this one is the water. And here's another one. It's the same photo. Like essentially what it does is makes everything look more evenly lit essentially. And here's some of the footage from the video with the most drastic change, I would say, with factories. Photoshop. It's really cool though. It makes the game look better in a lot of cases, but there's one major problem with it in the way that things are right now. And I'm just gonna jump straight to that. So I have another video here demonstrating that. So here's my little home I've made it myself. This is where I live. It's a little factory I made. It's running purely on packaged liquid biofuel, best fuel source. So this is with Lumen off, right? This is the default rendering method that we have in the game. This is what it looks like. It's a little home. Just look at it, running around here, looking around. All right. So now that we have that freshly mined, here's Lumen on. So you can tell that, like, I'm gonna pause here real quick. So like if you check the building, you can see that with Lumen on, it's like a little bit more evenly lit, right? It looks a bit more, yeah, evenly lit essentially. And that's all fine, right? It's more orange. Yes, it's like, because it's like bouncing around light on itself. But the problem is when I walk in, this is now what interiors look like when it's closed off from the environment. So the only light sources here really are from the benches and like the MAM. So if I remove them, it goes completely dark. Like this is what it looks like inside a factory. And this could be cool if this is the look you're going for, but it kind of makes the game unplayable unless you have lights, you know, installed. So this is really cool though. Like I'm not gonna lie, like this is so cool, being able to like open it up like this and you get like this kind of shading. But yeah, this is really one of the drawbacks of the way that when we just slap Lumen on without applying like any kind of render technique on top of it, it's just gonna look like this. So you really need lights in your factory, and that's was something I discovered when I was taking Bits' factory. It's like without lights, it just looks like this. So, but if I turn it on, it looks awesome, right? It's just we have flashlight. So also the flashlight doesn't really do much. The flashlight doesn't have that much like output. I was gonna demonstrate that in this video, but unfortunately the flashlight doesn't work in the current version. But one really cool thing though with Lumen that I kind of want to explain before I show this part is that Lumen takes everything and treats it as a light source, which is not typically how lights work in games. So there's something called an emissive texture or emissive materials rather, where what you usually do if you have like a computer monitor in a game, you usually apply a emissive texture on like the screen because it's lighting up by itself. But emissive textures do not light up the environment. This is an example. For example, the lights on some of the factory buildings are emissive textures. They don't emit any light, so they don't actually affect the environment when you place them around the world. But in Lumen, emissive. So usually, what you have to do is, if you do that thing when you want to have like an emitted light, you have to put like the computer monitor, put an emissive material on the screen, and then you put a light source where you want the light to be emitted in the game. So you actually have to, it's kind of weird, you have to cheat a little bit. So like you put the light source, you put an emissive texture, which is essentially just when you're shading the game on the GPU, it sees like, oh, this is an emissive texture. I should then ignore the general lighting coming from other light sources and just like render this as it is. So it's like emissive textures aren't really, or emissive materials aren't really rendered in the same way as other stuff is, and that's why you can get that effect where it lights up. Even if you have, like, even the lights in our game, they do that, right? So when you're looking at a light in our game, there's an emissive material, which is the light source, or like the light that you're looking at, which is purely white or whatever color you're shading it with. And then we also have a light source, like, that is next to the, which emits the light or whatever. But the cool thing with Lumen is that Lumen treats emissive materials at light sources. So let me jump back to the part of the video here. Where was it? It's over here. So the signs we have in our game, they are all emissive materials. And in Lumen, they actually emit light, which gives you off this like cool effect. Now, granted, you can't really light like properly because it's only rendering like the stuff around it. It's not bouncing the light from, you know, the source onto like the wall behind it and stuff like that. It's just the surface around it. But it looks really cool. And then if you go full on stupid mode, you could try and light the entire scene with just signs. And then it would look like this. And this is so dope. This is incredibly cool. And this was like one of the first things I did when I was goofing around in Unreal Engine 5. Was like the first thing I did was just like slap an emissive material on a ball and just put it in the scene and be like, oh my god, it actually lights up the shit. So that's really cool. And that's sort of, if you watch the footage of Bits Factory, if I go over here, you can see like Bits put down signs at the bottom here, and they kind of like emit a little bit of light on the ground. You can see it here. They also add like a little bloom and stuff like that, but they are affecting the scene more so than what they would have. Yeah, they affect the scene essentially is what I'm trying to say. But we won't be supporting Lumen like fully officially. So like, will we ever make it so that it doesn't go a completely horror game like this? I don't know, honestly. That's the thing, right? This is going to be an optional thing. This is not where we're going to put effort into it, because you really need to sort of light your game with Lumen in mind if you're going to use Lumen. And since we're not doing that, you know, you can on your own, but you will be able to have the option to turn it on if you want to. It's going to be like one of those optional things. Maybe you'll just do it for when you're grabbing the screenshots or whatever. And when you're playing the game, you just play it off. The game does run a lot better without Lumen. I mean, yeah. So Lumen is not more GPU intensive because Lumen runs mostly on the CPU. It's a software-based ray tracing technique, or a collection of software rendering techniques. So even if you have a monster of a GPU, it still wouldn't make it any better, unfortunately. One more thing that I kind of wanted to talk about before we leave Lumen and Nanite is that, or maybe this is a miscellaneous thing. Maybe, we'll get to that later, actually. Never mind. So another thing Jace talked about in the video is virtual shadow maps, which is just TLDR. It's like a way to make shadows more detailed and look better, and it's more efficient. And you can have higher resolution on shadows. But that only means something if you know how shadows are rendered with shadow maps. Because there's a bunch of different techniques how you can render shadows. And if you're using shadow maps, then there's a dependency of resolution, and virtual shadow maps makes it so that resolution is like more dynamic. But we're not using that, and we probably won't use that. But we'll see. Cool. That was Lumen and Nanite. Dope. So let's move on. And we just touched on the first bullet point, and we're an hour in. Okay. There's a reason why that video was 40 minutes. Okay. How Lumen works with vehicle lights. Lumen will work the same way with vehicle lights as they will with regular lights. So like, this is the same deal. We actually do emit light the regular way with vehicles, but Lumen will take the emissive material part of the vehicles as well and do that stuff too. Like, every light and every emissive material in the game will be treated the same way inside when you use the Lumen, essentially. All right, let's talk about the world partitioning system. This is the biggest fucking thing that has ever happened to Satisfactory. This is like one of the main reasons why we changed. And the biggest reason isn't necessarily that like we fix hitches and stuff like that. The biggest gain for us is how we work together on the game. Multiple artists working on multiple parts of the map. It's a huge, like, working on the world that we are, there's a huge undertaking. And working collaboratively on that stuff has been, it's been a headache, to be honest. I think. I mean, I'm not the one doing it, but it's quite obvious that like it's rough, and it's a huge world, and you know, we're doing the best we can. But adding the world partitioning system makes it so much more like easy for us to check out and check in stuff as we're developing it in our version control system. And yeah, we're just working on the tiles themselves and be able to configure them a bit more granularly. We've had a lot of tools made to be able to work on the world as it is. And now it's so just to clarify a bit. So the example is like if someone's working on the grasslands, and like previously somebody could be working on the grasslands and somebody could be working on the rocky forest, almost said rocky desert, like because those two were split up. But now it's way more granular. So now two people can work on the grasslands at the same time, so long as they're not touching the same parts, or the actors rather, on the grass fields. Previously everything was like loaded into one sort of chunk, and now we can actually work on the smaller bits on that chunk instead. We still have the chunks, but now we can define them a little bit more and make them smaller and make them make sense. So for instance, in the example with the northern forest that I have in the beginning here, you notice how like not the entirety of the northern forest was loaded in. That was not even possible in the world system, even though it doesn't look as good as it does right now. But like we didn't have that option before. So now we do have that option, and it makes it so we can actually adjust it more. And we might even do the thing where like we tie it into, I mean, I say might, well, I'm pretty sure we will, but we might even have the thing where, you know, you can have a setting in the settings menu where, like, based on the view distance, we load in less things. So if you notice you're actually running into hitches, you can reduce it and like adjust it more to your out of your necessity, and stuff like that. That will be possible. We don't have it right now, but that will be a possibility. So world partitioning system is a huge deal for us. And like, this goes for a lot of stuff here, where right now we're just kind of catching up the project and like migrating stuff to be using the new technology that's in Unreal Engine 5. So Jace mentions in the video that, like, you know, performance hasn't been drastically improved, actually is a bit worse than before in some cases. But now we're at the point where we can actually start like using a lot of the stuff that is available in Unreal Engine 5. And I'm really excited for the next couple of hopefully commits, because right now the game is really heavy loading in the engine, and we're going to be moving to, like, hopefully loading in virtual texturing for the HLODs, which doesn't mean too much of anything. That's the one thing that I'm looking forward to now, and I think that's where we're going to see a huge gain soon. But it's going to be better in the long run, essentially. It's going to improve the game for sure in the long run, and that's sort of why we want to do it now rather than like after 1.0 or whatever, because this is the best moment, really. Like, this is the best opportunity we have to do it. So that's what we're doing. So I don't know if I need to talk too much about the world partitioning system. I think Jace covers I haven't seen too many questions on the world partitioning system. I think people got that stuff. So there's not too much to clarify there. So check the video if you want to see more information about that stuff. I guess I could show off again the I have a video here, or I have in the video we sort of showcase like how it would work. So now instead of how it used to work is you would pick a tile, you would pick like 3x4. And it would load in like that segment. But now you can like select like with the mouse, like, here, I want to load this part. And it loads that region. And it's so cool. It's so useful, because if we move here a second, I'm going to show you why this is really useful in a bit. I think it's not this one, but I think it's the next one after that. No, it is this one. Okay, so if you check here, this hill over here hasn't had the cliffs loaded in. So like, this looks really strange when you just look at it like this. But when I load in that portion of it in a second, boom, the cliffs are in. So like, you can, I hope this demonstrates just how fucking like granular it is. Yeah, it used to be an octree, exactly. So super dope, super dope. And then I keep going. Just keep going. Load more shit. It's also funny because the world partitioning system also functions like sort of in the engine in a bit. So when you're moving around, so we can actually load the entire map. I don't know if that was really possible before, because I think we ran out of space. I think we ran out of VRAM when we did that before. I never did it, so I don't know if maybe it was possible to do it before, but like when I'm in engine now, I can actually load the entire world at the same time, which is pretty cool. How easy or hard was this feature to implement? That I don't know. It wasn't, no, I don't want to watch him. It wasn't, none of the stuff here was like just push of a button. I know that they said in the video it just works. Fuck that shit. It did not. It still doesn't work. It still doesn't just work. Not true. But a lot of stuff is sort of sometimes we made custom engine edits, and if we touch too much of that, it's an issue. And I believe we had to like make some tools to be able to move the world over to the current iteration. So yeah, that's the world partitioning system. I don't think there was too much else. I don't, should I be taking questions while we're doing this stuff, or should I save it for after? I think I should be taking questions while we're doing this, actually. That's a baddie on me. That's a baddie on my part, because I realized if I save everything for the end, we might not have time for questions, and I really, really want to spend this time on stream answering questions. So yeah, I'm gonna try and keep track of that more, actually. The world partitioning system will not affect drones. So the way it works, the way we've set it up is we have sort of two maps. We have a persistent map, and we have the stuff that you see like in the world that's sort of not tied to factory logic or tied to pickups and stuff like that, and not a nodes. So we have a persistent level where all the nodes, all the factory logic, all the nodes. I believe the hard drive stuff, like all the crash sites, like a lot of the gameplay related stuff are loaded in separately, and we load in everything. So no matter where you are on the map, your factory's running no matter where you are. We're not unloading the factory. We're unloading like the meshes, and we're not making them render and stuff like that. And we're making, I think we have like proxy models or proxy actors for those, for all the factory related stuff. So like the logic will always run, okay? It would be weird if like you unload a factory and then come back to it, nothing's happened. And the drone like routes are all on that persistent level. So the world partitioning system doesn't touch that. It just touches like what the environment looks like, you know, what models are loaded in, what you're looking at, and stuff like that. Yes. Cool. Cool, let's move on and talk about TSR. Maybe we'll have time to have like a fully owned QA section, but I'll do my best. We have so much to cover. So TSR, temporal sampling resolution or super resolution? Can't remember. There's another upsampling technique that has a similar name, but I think it's temporal super resolution. I gotta check it. Yeah, super resolution. So we'll talk about TSR, which is temporal super resolution. We'll also talk about FXAA, which is a it's another anti-aliasing technique. There's gonna be like 4, I think, or 3 different anti-aliasing techniques available in the game. Jace mentioned in the video. I'm trying to find the notes here. It's not in the notes. That's annoying. But yeah, TSR. TSR is used for being able to render lower like resolution and scale it up. It's been historically very useful for when you're rendering the game in 4K, because 4K is a lot more screen space than regular 1080p. So it's been really useful, but it's also useful even if you don't have like a machine that can render 1080. Like you can still downscale it and scale it up. Typically, these type of scaling techniques are usually better when you go like the higher, the higher the base value of the resolution, obviously the better the final output is going to be. So for instance, when you're rendering from 1080 to 4K or 14, not 4K, but the one before, 1440p, when you're going from 1080 to 1440p, usually the result is better than when you go from 720 to 1080, if that makes sense. Like because of the amount of the pixels and the way those techniques work. So it's like, it's more useful for people when you're rendering from 1080 to 4K rather than when you're going from like 720 to 1080, typically, like in terms of fidelity of what you're looking at. But it's still a really powerful technique. Now, one thing, the kind of elephant I want to address in the room that's kind of strange is historically, I've already seen a couple of questions about DLSS, and I also want to mention what's it, FSR, AMD's version. A lot of people have asked us in the past if we're going to do DLSS and FSR, and in the past we've often said that we probably won't because we didn't see a significant improvements. Like we didn't see any significant improvement when using DLSS or FSR with our game. But with TSR, we are seeing that improvement, which is kind of strange. And I don't really have a good answer as to why that is. There might be a couple of factors, and maybe if we test out DLSS now, maybe we'll notice a better gain. But the thing is, you sort of have to adjust your game based on these techniques because they work in very different ways. TSR and DLSS they achieve the same thing, but under the hood, they work very differently. DLSS has an issue as well where I believe it can bottleneck your CPU. So that might be why we're seeing a difference in performance when using DLSS versus TSR. I don't know. I tried to dig into like why we would be seeing that, and I couldn't really get a consistent answer. But there was something about how DLSS, like if DLSS can't catch up, it will bottleneck your CPU, which will create this like weird, what do you call it, like Mexican standoff? No. Whereas TSR is a lot more like, it's a lot easier on the CPU than DLSS and FSR is. So out of the different techniques, we found that TSR works the best. I know that, at least from my experience, that I find that DLSS is a bit better quality-wise, I think, if you compare the two. But TSR is more performant, it seems. And it's more lightweight on the CPU, what it needs to do. So that's one aspect. The other aspect, like I mentioned here, is that you sort of have to... They are two different techniques, so you sort of have to like do a little bit of a special thing in the game to make them look good as well. So one issue we had when we were testing out DLSS was that all moving parts, all moving factor parts, looked like garbage on DLSS. So like all the arms animating when they're like, moving and doing stuff on the factories, all the stuff moving on the belts, like that was completely broken as far as I know. And it was a lot less work to get it working with TSR than it is to get it working with DLSS. So I don't know if like in the future we're going to be supporting DLSS or FSR, but I think at the moment we're still not going to support DLSS or FSR because TSR kind of fills that gap that a lot of people are after. Also, TSR is supported on more GPUs than both DLSS and FSR. I know that DLSS has gone back in like being able to support older GPUs because when we started looking into DLSS, it was like it was only supported on, I can't remember, one of the later GTX like cards, and there was such a small percentage of our player base that had like that could support DLSS. So it didn't really make much sense for us. Whereas TSR is supported on all the cards that we support, essentially, I believe. Epic adding native DLSS support EU. So I believe that's TSR. I don't believe Epic are adding native DLSS support to Unreal Engine because they made TSR. I think they kind of chose to go that route instead. It is possible that they might, like, there is DLSS support. It's just you have to use a plugin, and I don't know if that's natively supported by Unreal, whereas TSR is natively supported, like, out of the box. It was not a tick box before. No, it was, you actually had to import the plugin and stuff like that. So that's why we're going with TSR. I don't know if we're going to use DLSS or FSR in the future, because we also need to put in that work, and we'd rather put in the work and other stuff. And if you want to use those techniques, TSR is there for you. But we'll see. We'll see. What else was there about this? Yeah, I can't remember what FXAA, if it's just fidelity anti-aliasing, but it's like a faster anti-aliasing technique, and I'm actually quite surprised of how good it looks. I honestly prefer FXAA over TSR in a lot of cases when I've been testing it out. So I think, yeah, thank you. Fast approximate anti-aliasing. Thank you. That's what it is. When I've been using in capturing footage, I was bouncing a lot back and forth between TSR and FXAA, and I just found that FXAA creates less artifacts, because it's still going to be an issue in TSR when you're using it. There's still going to be like artifacting. There's a couple of instances where if you have, like, you know, the outline around containers and stuff like that, if you're very close to objects and you have TSR, like a high amount of TSR, like if you're rendering, say, 60% of the screen or whatever, and you're moving the camera around sporadically, there's going to be like white lines all over the screen, which I find a bit annoying. There's also stuff with the skybox. I don't know if that's something we need to work more on, like supporting wise, but same thing. If you look back and forth in the sky, the clouds look really strange and stuff like that. So yeah, a lot of times when I've used FXAA, I've found to get better results than using TSR. But I think whenever it comes to this kind of stuff in general, it depends on the circumstance. So like maybe in some cases FXAA is better, and in some cases TSR is better at other ways, depending on the situation. And that's really how it is with a lot of these type of any rendering technique, really. But yeah, I don't remember which ones we're going to support at the moment, because it's not here in the oh, I've just found it in the notes. Here it is. I think it's TSR and FXAA. There might be support for what's we have a default one right now. That's still going to be there, of course, but now there are more options for anti-aliasing, essentially. Cool. I think we're going to move on here, unless there's any specific questions about this that I haven't brought up. I'm getting a little bit of support here, like there's a pain in the ass to set up FSR DLSS. Yes. I don't think I'm pretty sure we had to do something to get TSR working with the game, because it's still the issue. You still need to, like, if you have moving meshes, you need to do something special with them to be able to get them to render properly in TSR. So there's been a bit of work put into that. TA can have nasty ghosting and blurs. Yeah, so that's the thing, because I found well, at least in the situations when I was testing, I found better support. Like I found it to look better with FXAA than TAA, which shouldn't be the case. It should be the other way around. So it's like it's faster and also looks better, at least when I was testing. Maybe I needed to run around more factories and stuff, because I was mostly running around in the environment. But yeah, sea fighting is nothing. Has nothing to do with it. Although there can be circumstances where, when there's a lot of Z fighting and you're upscaling it, the Z fighting is going to be less pronounced. Well, it depends, because it depends on angle and stuff like that. There can be cases where Z fighting is less pronounced in lower resolutions, and then you're upscaling that. But you might instead end up with a lot more artifacting. So it might look, you know, it's like up for debate whether it looks better or not. But yeah. Cool, let's move on, because we're running out of time. Holy shit. Chaos physics. Yo, chaos. The vehicle changes are so dope. They are hella broken right now. Like, parts of the vehicle overhaul is so much better, and part of it is so much broken right now, but that's because we're moving over into the chaos engine. Like, driving around in the vehicles and all this stuff feels so much better now. The only issue is like all the automation with vehicles. So like when we're simulating stuff, there's some janky shit going on at the moment. I hope we can iron all that stuff out before we release update 8. But so stoked to be able to drive around on foundations and stuff like that. That's like one of the biggest, really, like, reasons why we wanted to move using Unreal Engine 5, because we knew we needed to rework the physics for the vehicles, and we sort of put it on pause because we were like, maybe we'll move to Unreal Engine 5 and then we could do it there. So like changing the vehicle physics was like the first thing we started looking into when we were contemplating moving to Unreal Engine 5, because that was where like the biggest gain initially. We thought. We also realized that the world partitioning system was quite big, but initially we were like so stoked about the fact that like maybe the vehicle system will work so much better, and the physics are much better. I haven't tested it like an insane amount, but I have been driving around on the map a lot, and there's still like a few cases where there might be cases where like, why did the vehicle just bounce around like that? But if I compare it to like how it is now, it's like, it's still less amount than it was now. There's been a couple of cases where like I'm driving up on like nodes, like ore nodes, and instead of it being like, acting on with the wheels on it, it still like just flips. So that's kind of strange, but maybe it does that now. Does the physics update affect how stable or janky vehicles are in multiplayer? See, that's a good question. I actually don't know at the moment, because there's undoubtedly aspects of it that we'll need to like not only change how the physics work for the vehicles for the game itself, but also like how all that multiplayer support will be. I actually don't know. I haven't tested that actually. But if anything, I think it will be better in multiplayer. But you might still have like it's like, so here's the thing, right? Because it's kind of, there's two aspects of it. You have the vehicle's physics as they are, and then you also have like the networking physics simulation that's going on. Because the way it works is, the way it doesn't work is you have a server and you have a client. And the server's telling the client like, hey, you're driving a car, and car's over here, and then their server's like simulating what's going on. Like, it's not possible to do that, because you would need to send, because most often physics operate on like a lower tick rate than what the game is updating, to be able to simulate what happens between the ticks, so to speak. Because the game, if you're running the game in like 60 FPS, it's not tied to FPS actually, never mind that, but imagine if you're running the game at 60 ticks, 60 hertz, that might not be granular enough to be able to get like proper simulation on wheels, because there might be stuff happening between the frames or the ticks, where you'd need to like know what actually happened. And it's not really possible for a server to be able to send you that information, because it's so much data. So what we're doing is we're simulating the physics on client, and then the server is like making sure that we're where we're supposed to be. And if we're not where we're supposed to be, it will, I don't know if we're rolling back, or if we're using rollback, or if we're using some other technique, because it can be, there's plenty of ways to solve that problem, and it's a huge problem. But it will sort of adjust to make sure that we're in where we're supposed to be. But before we simulated the physics, this was janky as shit in our game. It was so broken. I'm so glad we did that. I think that we did that for update 4 or 5. That was quite a while ago, where we started simulating vehicles on client, and made the game so much better using vehicles on client. But there's still there can still be issues where clients don't match up. So changing the physics to use chaos shouldn't affect that portion of the game, so to speak. So like the simulation aspect of like whatever physics engine you're using, that will still sort of be its own problem, if that makes sense. And that's a problem that we have semi-solved, and now we're applying a new physics engine on top of that. But it's the same physics engine. So yeah. Let's see. How did it work in Halo 2? Halo 2 is probably... I don't think Halo uses rollback. I think Halo just like warped you. It just moved you to where... I think there was like it had like a granularity of like if you're too far off where you're supposed to be or something like that, it would move you back. I don't know, because it kind of depends. Like some games don't really need rollback. I don't think we have rollback. I think we just warp you as well. Because rollback is when you keep track of like where the client thinks it is and when the server knows it is. And then when there's a mismatch, the server will ask the client to go back in time and then reapply the same input from the player. I don't think we're doing that because we don't really need that fidelity. I think we just move you to where you're supposed to be and then be like, all right, and then you're in this vector and you have this velocity. But I don't know. I actually haven't worked on that system too much. It just warped back? Yeah, that's what I thought. Because when you're using rollback, usually it's tied to like player input is the main buffer that you're sending data. So you would know what you were doing in between as well when you're doing rollback. And it's a lot more work getting rollback working than just like moving you back. But I wouldn't be surprised actually if Halo was using a rollback because it is a fast, maybe on the later Halos for sure, because it is a faster like shooter. Call of Duty uses rollback, I know. They have like their own special fucking magic where it like guesses what's gonna happen player input wise. It's so weird. That is like actual magic. Cool. That's physics. I don't know if I need to talk too much. Yeah, no, I do have to talk about one thing because I had a lot of questions about like the other physics, because we only talked about vehicle physics, because all the fixes in the game are going to change. Player physics is going to change. And I've gotten a lot of questions of whether or not hypertube cannons will work in the same manner, or if whatever. And yeah, so player input wise, we're using the Unreal Engine like player movement logic. So that has already been like ported by Epic. So we haven't done anything special there. We're just using the system that they have, and that has been migrated to using Chaos. So like we're out of the woods for player movement and stuff like that. But we have a little bit of like special logic when it comes to hypertubes. And for the most part, if you don't have like any advanced kind of physics, it like just migrating should just work in Unreal Engine. But here's the thing. When I've been testing, the hypertube cannons actually don't work at the moment. They're kind of broken. But hypertubes seem to work, which puts us in a very strange position right now. Wait, don't freak out yet, okay? Because that puts us in a pretty strange position because we kind of like that feature. So I talked to Mark about this. So we have like internally decided that hypertube cannons is going to be like an official feature. Like we're going to support hypertube cannons. So we're going to have to fix that bug to make it work. It's like, it's such a strange situation to be in, because like hypertube cannons historically was not intentional. Hypertube cannons were sort of like discovered by community, and we were like, oh, that's a cool bug. Let's not remove it. You know, let's keep it. But now we're in a situation where it kind of doesn't work anymore, like because of the physics change. And yeah, like I mentioned, we kind of view that as like a core feature now, or a feature. Even though it wasn't an intended feature, we kind of see it as like we don't want to remove that anymore. So we're gonna try and fix hypertube cannons. Hypertube cannons might not work exactly the same way as they did before. It's a similar type of problem with like the vehicles. Jason mentioned the vehicle in the video, where it's gonna pretty much be the same thing, but it might be some slight change here or there. Because it's really hard for us. It's really hard in general to like be able to like replicate in one physics engine exactly how it works in a different one. So like if you had if you tune your hypertube cannons in a very particular way after update 8, we hope that they will still function, but you might need to like adjust them a little bit or something like that. Maybe they'll be less powered, or maybe they'll be more powered or something like that. I don't know. I think the goal is to have it so that they pretty much work the same way as they did before. That's the goal, at least. But I just wanted to like be transparent about that and explain the situation. Because I sort of discovered this when I was testing that some of the hypertube cannons that I'd set up just didn't work, and yeah, that's a bummer. What about slide jumping? So slide jumping was one of those cases where we sort of got that automatically because Epic, when they implemented chaos physics, they sort of took the player controller and applied it in a similar fashion as it works right now. So the slide jumping and stuff like that pretty much worked the same way as before. I haven't tested on running on conveyor belts. There's probably a bunch of stuff we haven't tested yet when it comes to physics. But the goal really is, like, all that stuff is to be able to reach the same point as it is with the current physics engine. And yeah, the hypertube cannon functionality, I guess, is gonna be official. I guess. I don't like it. I don't like that it's an official thing. But that is definitely something we don't want to rob you guys of. Yeah, just so you guys know. Confirmed, yes. That is the goal. All right, let's talk about audio. Because I don't think there was any question left on chaos. I can circle back on this if there's time. But this I don't have too much to talk about audio. The only thing I want to mention is that we're not using Epic's like new meta system or whatever it's called. We're still using VWise, which is probably going to be... I believe for the mod creators, they're going to be annoyed to hear this. And we're also partially annoyed because VWise isn't super easy to use. And we also have needed to make like... We needed to make like a bunch of F special stuff for VWise, but it like... We have put so much work into VWise, so I think that's mainly the reason why we probably will not use anything else. But I'm just checking. Yeah. There will be like a couple of audio changes though in the game. There's new additions for audio. There's more like detail for audio in a lot of aspects. We talked about in the video, the vehicles have like simulated audio for the wheels and stuff like that. There's audio for stuff that didn't exist before until now, and stuff like that. But I think you guys are probably gonna notice that when you're playing this self. I don't know if I should list things. But in regard to like Unreal Engine 5 for update 8, we're not using meta sounds. We're using the good old VWise. So yes, I don't know if there's too much more to talk about. So I have just a miscellaneous note here. There's a bunch of stuff. One really important thing I want to talk about is hardware requirements, because this was probably one of the... I don't know why I saved this for last in the stream, because this is actually one of the biggest topics that I've seen people talk about after the video was released, is that a lot of people were worried that they won't be able to play the game anymore, because we had to upgrade the... we released like a preliminary new minimum specs, which was the GTX 1650, 4-core CPU, 8 gigs RAM, and an SSD because of how Nanite works. And I just want to mention really quickly that, like, let's see here. Like, all the footage you've seen here when I was doing the thing, like, maybe this is a better one. Like, all your footage you're seeing here, this was captured on a 1080. Now, granted, 1080 is still one step, I believe, after 1650. But I think my point is that don't like buy new hardware before you've tried it out. Because yeah, buy a 1080. It doesn't run great on a 1080 though, I'll tell you that much. I'm getting consistently 30 FPS with Lumen on, I should add, by the way. But like, I've played the game a lot on my machine at home, and I mean, it works. What's wrong with 30 FPS? Andrew, get the hell out. I mean, it works. Like, you can play the game fine on older graphics card. Granted, I don't have a massive factory, but I'm at tier 5 or 6, and it runs pretty smooth. So when it comes to the hardware requirements for the game, don't get too like choked up on it. I actually don't know how we've determined these specs either. It's possible that we just followed like one of the guidelines from Unreal Engine, where like, yeah, they're like, oh, if you're making an Unreal Engine 5 game, then you need to have this, at least this. It might be the case that like they're anticipating that you're going to be using a lot of Lumen or a lot of the techniques or whatever, a lot of Nanite, stuff like that. But we're not really using all that new stuff, I guess. So I mean, the only thing really is that the goal really is to support DirectX 12 is the default renderer for us. So any GPU that has support for DirectX 12, will be able to run the game. So yeah, try it out at least before you start buying like a bunch of stuff. I have GTX 1060. Like, that's the thing. I think the game will run. I think famous last words. But I don't know. 1060 and 1080 were a big leap, maybe. I don't know. But do consider not like be too worried. We'll see when the update launches. That's when we get worried whether or not we've made a big leap. But it's sort of like the way the story goes, like the cookie crumbles in a way, because we are using a lot of techniques that will make the game better, and we are moving forward in time, and a lot of stuff is getting deprecated. Like, we dropped support for Windows 7 because Microsoft dropped support of it. One of the reasons why we dropped support for the current GTX, like the GTX 770 on the website, was because that card is no longer supported. So there's no point in us saying that we are going to support it. So really, if you have any GPU that can use DirectX 12, should run. But I don't know. It's tricky. Defining like minimum specs is so hard. Like, what does that mean? Because in the world of computers, there's so many factors that can play into it. So I don't know. So panic once we release it, then we can talk. But definitely 8 gigs of RAM on like when you compute, like, holy shit, you need that. God damn. So yes. Let's see. And then we mentioned DirectX 11. DirectX 11 is still somewhat supported, but we really want people to move over to DirectX 12. Because that's the target for us. DirectX 12 is the target API, rendering API, when we're like optimizing the game. Vulkan is like second, but Vulkan isn't something like Vulkan is in this weird state where it's like Vulkan isn't fully supported anywhere. It's like a very promising rendering API, but similar like to OpenGL, Vulkan is still in development, and some would even consider Vulkan to be an early access, in a way. It's infantile stage. Yeah, exactly. So like, and then Vulkan by itself is still kind of in a work in progress, and then you have the Vulkan support in Unreal on top of that. But we still prefer Vulkan over DirectX 11. I'll say that much. Like, if you're gonna try another if it doesn't work in DirectX 12, then Vulkan is the next best thing, really. And last is DirectX 11. So yeah, I think I've caught most of the... I've talked about the topics where I saw a lot of confusion from people. Not a lot, but like where I saw confusion. I talked about hardware, talked about Lumen, talked about... yeah, this is essentially the Q&A section if you have any specific questions about the stuff. I didn't talk about the input system. The input system, you know, it's an input system. You guys won't really notice. Like, it's not something that you guys can take advantage of. It's just like something for us to take advantage of.